Today we're going to talk about the gravity-assisted solenoid motor, and we're actually going to see it in operation. We've got our power supply on, about 30 volts, and it runs down through some cables and through this meter so you can see how many milliamps it actually draws. And I wanted to talk a little bit about this commutator, and this is what it looks like when it's wrapped with foil tape. And this is it. This is another one on the machine itself. It has a set screw in it to keep it from turning on the shaft. And you can see over here that this strip goes all the way around, and this has been cut away. So that gives us our switching action. And about 95 degrees of it have been cut away on one side. So that turns it into a switch. And then this up here is epoxy. And that was done on a flat plate. If you look at this, you can see that these were taped down to a flat plate and then masked off with masking tape, and you just put epoxy in the little rectangle, and then it holds these brushes at the proper spacing so they line up correctly on the wheel. And then everything's wired in. There's power going in to the switch. Over here, power going in, there's power coming out of the switch, and it runs back around here to the solenoid on one terminal, and then this other terminal up here goes back up to the power supply. And also I want to talk about these yellow wires right here. They run over here to an AC capacitor. Now this is a 45 microfarad 450 volt AC capacitor. And this is part of the feedback circuit that actually makes the thing run faster. And as you can see down here, with the capacitor on, with this 45 microfarad capacitor hooked up, you get 525 RPMs. Only 450 RPMs with a 1 microfarad cap on it. Now you do have to have some kind of a capacitor, even if it's a small 1 microfarad like this, or a 0.47 microfarad like this. You have to have something, otherwise your brush assembly will burn up from the feedback voltage that's on it. So at any rate, we're going to give this thing a little push because it's not self-starting. And there it goes. Now it's running. And you can see this meter down here is set for 200 milliamps. And it draws about 82 milliamps. It's hard for the meter to get a reading because it doesn't like the high voltage spikes. But at any rate, it's pretty good. Not too much sparking on the brushes. You really can't see any. But you absolutely cannot run this without some kind of a small capacitor like one of these, or a big capacitor like this. You have to have something. Otherwise, you'll burn this assembly up. Because the feedback voltage will light it up. Anyways, that's it for today. Just wanted to post a little something of it actually running.